let's think about what 32 to the power 1/5 is going to be like. So far we have done base to an exponent where exponent is an integer. When we did, for example, if I said 32 to the power 5, that would mean take 5 copies of 32 and multiply together. What do you think 32 to the power 1/5 would be like? You want 1/5 copies of 32 multiplied together. So what do you think we should imagine that to be? Maybe this will help you. 32 is the same as 2 to the power 5. 5 copies of 2 multiplied together to give you 32. So 32 to the power 1/5. We want 1/5 copies of 5 2's. If there are 5 2's, then a fifth of those would be 1, right? So it'll be 1 2. So it would be logical to think that 32 to the power 1/5 should be 2. Well, if that is the case, then what do you think would be 25 to the half, 27 to 1/3, 49 to half, -8 to 1/3? Use this set of questions for video log, and even though we haven't spent a lot of time on it, I want you to think about what these numbers would be, and when you come to class, you should be able to defend it. Here is another way you can think of fractional powers. For example, if you look at a square or a cube of side length a units, area of a square is given by a squared, volume of a cube is given by a cubed. And so we can think, if you have a number a and b are positive real numbers, we can think of a to the 1/2 as length of a side whose area is a squared units. V to the 1/3 can be thought about as length of the side of a cube whose volume is V cubic units. So that's another way you can visualize at least the half and the 1/3 power. But let's take an example. If you have a 9 square centimeter square, what would be the length of it? We're saying 9 to the 1/2 is how we should think of it. So 9 to the 1/2 would be 3, because you can see in the picture here 3 by 3. 3 squared is 9, and it's consistent with what we've been saying. Half of 3 squared, we want half copies of 3 squared, which would be a 3. And similarly, if you look at a cube, here's a 2 cubes, so that's 1 2 3 4, 1 2 3 4, put them together to form a cube. And so our length 8 to the power 1/3 can be thought of as length of this cube here. Now there are other ways we can write fractional powers, and that's introducing the concept of radicals. So in mathematics, radicals play an important role. So we're going to do connection between the exponential notation that we've had and the new notation we're introducing, and we're going to call that radical notation. That's just another symbol for rewriting exponential notation. For example, a to the power 1/2 can be written as this square root sign and then a inside. It's almost like a is sitting inside its own house, the square root. When it's 1/2 power, you don't write that 2 there, but if it was a 1/3 power, you'll write the 3 inside that little wedge right here. So a is the base, 1/2 is the exponent. This is called the radical sign, and a is called the radicand, which we'll talk about in just a little bit. So a to power 1/5 would be 5th root of a. That's how you read it. You can say 5th root of a, or a to the 1/5, or a to the 1/3 cube root of a to the 1/2 square root of a, 1 over a to the power 1/2. 1 over a is the base. The base becomes the radicand, and then you have the square root sign. A to power -1/3. Remember how we said negative means take it to the denominator with positive exponent 1/3, and positive exponent 1/3 is cube root of a. So a to the -1/3 would be 1 over cube root of a. A to the power 2/5. We can think of 2/5 as a to power 1/5 bracket squared. So 2 copies of a to the 1/5, or 5th root of a squared. We will visit this last one again when we do algebraic operations on radicals. But I want you to get comfortable with the notation that when you have a to power 1/3, you can write cube root of a. A to power 1/5 would be fifth root of a. A to power 1/2 square root of a. So another notation we've said is radical for exponential powers, and the way we're going to look at this as if a is a non-negative real number and n is a counting number, we define a to power 1 over n equals nth root of a as a number that when raised to nth power gives you the answer of a. So we're defining nth root of a going to be a number so that when you multiply this number n times, you end up with a. So for example, when n is 2, we write square root of a as a convention without the little 2 in there. If n is odd, we can have a be any real number because you can take odd radicals of negative numbers, but you can't for positive, and we'll see why that is in the next module. So here's an example. 25 to power 1/5 is square root 25 is 5 because 5 squared is 25. Look at the definition. A to power 1 over n. 25 to power 1 over n. We're saying whatever the answer is to this, multiply that twice and you should get the original number, the original base of 25. So cube root of 64 is 4 because 4 times 4 times 4 is 64. Don't worry too much about simplifying. Right now we want you to just get comfortable going back and forth between exponential notation and radical notation. So 3 to the 1/6, what do you think we should write that as? Go ahead, do it on your own. It will be 6th root of 3. Eventually, you're going to have to do a video log questions on this. So make sure you understand how this connects. What if I gave you cube root of 5? What would be going the other way, the exponential notation? So 5 is our base, and 1/3 would be our power. So square root, remember square root means 1/2 power. 1 over a to the power 1/2. So 1 over a is your base. 1/2 is the exponent. In this notation, 1 over a is the radicand. Square root is going to be the notation you're going to use. A to power negative 1/3 is the same as 1 over 8 to the power 1/3. So we're going to have to write that as 1 over cube root of 8. X plus y to power 1/3. The whole x plus y is your base. So the whole x plus y goes inside the radical sign and the little 3 to indicate the 1/3 power. So rewrite exponential notation using the radical. You rewrite the exponential notation using the radical notation for your video log questions. Pause the video and write these down. And then the next set would be, next set would be going the other direction. You have radical notation, give us the exponential notation. And so now let's formally take a look at some of the terminology that we're going to be using. When we write a to power 1 over n, a is the base, 1 over n is the exponent. When we write in the radical notation nth, then the radical sign, and then a is called the radicand, and n is called the index. You can think of nth root of a as taking copies of this number. N copies of that number multiplied together is going to give you your base a. That's what that number is going to be, as we saw before. So a is the radicand and in the index. Just like you got comfortable identifying base and exponent, it is important to identify the radicand and the index. The radical sign, when you just write square root with no number here, becomes square root. If you write a little number here, then it becomes the radical notation for nth root. If index is 2, then we have square root and we don't really write that little n there. You just write square root. Just that symbol. So for example, if I write square root 25, then 25 is the radicand and the index is 2. You can also, as soon as you identify index, then you know it's 1 over 2 is the exponent for 25. That's why I'm making you be comfortable with identifying what is the radicand and what is the index. Cube root 64, 64 is the radicand, index is 3, or you can even think of this as 64 to power 1/3, right? Or cube root. Here, what do you think is the radicand? Radicand is always the thing that sits inside the radical sign, the whole thing. So 7 is the radicand, 5 is the index, and the fifth root is what we're looking at. Here, 3 minus 4a is your radicand, and 4 is your index. So now get ready for some video log questions. There will be radical notation popping at you, and you have to identify what is the radicand and what is the index. So for example, in the first one, 6 would be the radicand, 2 is the index or square root. All right, so do it on your own. Pause the video when you need to. If the numbers are going too fast, pause the rewind so you can do all the problems. Remember here, the radicand would be 3x.